species. However, you can do it in the lab. This famous fly, Drosophila, is a fruit fly, basically, if I'm not mistaken, in the lab. And that, has like a generational span of a couple weeks. So if you can breed a lot of fruit flies, a month, a year or something, and see them in the lab, and they can change, you can see that because their generations are much more shorter than, say, an elephant. And again, the third thing is that it's not individuals evolving, it's idea of populations. Many groups, all the finches in the Galapagos, all the bees in North America. It's not one individual and they go and they evolve. It doesn't really work that way. And finally, as I'll show in the next slide, it is not goal-oriented. The idea here is that there is no, as Anthony said, no end product of evolution. It does not have a set goal in mind. There's no best thing out there, really. It evolves and changes as the Earth and the environment changes and evolves. And so, many of you have seen the game Spore. It's a pretty fun video game. It's a computer game. And it was created to model this kind of evolution-like effect. So what you do is you start out and you have this alien asteroid or something from outer space. He smashes into this planet. You get some DNA and other biological things flung into the ocean. The things swirl around, and you get to choose one of these little bacteria or little life forms. And you fight your way out in the ocean. You eat other little bacteria, and you evolve and you evolve and you evolve, and you get bigger and bigger, and eventually you evolve onto land. And the point here is that you can choose the things you want. So this guy, as you can see, you can have multiple scale types if you want, green scaly eggshell, you can have that. If you want a smooth, pearl body, you can have that. And this guy has, big, like swamp feet with claws on them. And this person who made this one has to give him, like a bandsaw on his tail. So you can choose all these things, and see what works best. And then you fight it out and take over the planet and eventually take over the solar system. So if you haven't got the game, if you've never played it, I would recommend it. It's a pretty fun game. But unfortunately, it's not the best explanation of evolution. Again, there is no goal of it. There is, we're not trying to take over the solar system, allegedly. Okay, and so it is just a theory, right? You hear this often, but it's just a theory. Well, not exactly. Okay, so what is a theory? Well, in science, a theory is a comprehensive explanation of some aspect of nature that is supported by a vast body of evidence. So it's this idea of an amassed amount of data, observations, explanations, all these things coming together. And it is the highest product of scientific endeavors. So, you have your facts and observations that you find out, and then you work up an hypothesis and an experiment, and eventually all these things come together, all the experiments and data, to form a theory. But, in common usage, theory is just a conclusion based on fragmentary or inconclusive evidence. So the idea is that, well, I had this theory, that, like, this is how the Terps are going to win the football game. I have this theory that if you use more defense, they'll win the football game. Well, in common usage, it works that way, but for science, it's much more rigorous. So a good example of this is gravity. And the idea being that you can disprove or change a theory if you have the data and the facts to support it, but facts cannot be changed. So we know that gravity happens. If you throw an apple up, or if you're Isaac Newton, apple falls in your head. It's been like that. It's always been like that. Probably it'll be like that for a long, long time. And that is a fact. Gravity is a fact. We know it's a fact. But the theory of gravity has changed. Early on, we didn't even know how to make a theory of gravity when we were young humans. Then Isaac Newton's time, he made this theory, the famous theory of gravitation. Rigid bodies, 1/r² law, things like that. And nowadays, we've even changed that some more. Relativity. This is a picture, of like a black hole accretion disk with quantum mechanics. So even today, we're still modifying the theory of gravity. We don't understand it fully, but This does not change the fact that gravity exists. And so, the theory of evolution by natural selection. As before, evolution, like gravity, is a fact, and natural selection is a theory. And so, it's been said by famous scientists that the evidence is overwhelming. And the idea of natural selection is a natural process that results in the survival and reproductive success of individuals or groups best adjusted to their environment, and that leads to the perpetuation of genetic qualities best suited to that particular environment. And so far, natural selection is the best theory to explain the fact of evolution. In fact, we were talking with one person in our group, and I went to see one of the professors here, Dr. St. Ledger, and he explained to us, and perhaps it's another famous quote, that there in fact is more evidence for evolution than for the world is round. So we've known for a long time, right? The world is round, it's a sphere, pretty undebatable. Well, the idea being that there's more evidence for evolution in general than for the Earth being round. And so I'll just end here with some useful definitions that will be used in other presentations by the presenters. And so the idea of a gene. What is a gene? You hear this often. A gene is a unit of inheritance, and so it's a part of DNA used for a particular outcome, and that's the most common parlance you could use for that. The idea of it's like a small coding bit. It's the smallest thing that can tell proteins and tell functions how to work. So that's what a gene is. What is mutation? Mutation is a mistake in the DNA coding caused by the cell itself or other forces. So when a cell splits, the DNA must be replicated, and the body and the cells are very, very good at it. They have one mistake in 1 million or 2 million or 10 million or some number, some very large number, but mistakes do happen. These cause mutations. Or, if you live near the Hiroshima or Nagasaki bombs, you get dropped with just a blast of atomic radiation, that could also cause a lot of mutations in your body. Those radiated particles rip through you, and those strip your DNA a lot more than your body would. So there's multiple ways that mutation can happen. And finally, evolutionary fitness. This is an organism's capacity to produce viable offspring. And so before, like the finches have the most fitness for their area, for eating their food, or for living in their environments, were best suited to that environment, and they had the highest evolutionary fitness. And so, with that, I will turn it over to John.